Hello everyone, this side Priya Bhatia, and in this particular video I'll talk about exploratory data analysis. I hope you all know that this is one of the very crucial steps whenever we are doing any sort of data science project. And what I have observed is that many students have missed that what are the most important crucial points which we need to take care of whenever we are doing EDA of any data that we have. So today in this video what I will do is I'll take one random data and I'll try to show you few points which I believe everyone should take care of whenever they are doing any EDA task on top of any sort of dataset that they have. So let's get started. So here if you will observe, what I have done is I have taken the dataset from Kaggle, which is open source data regarding the diabetes. Now, if I will show you the dataset, just now after a few minutes, I'll show you also, you will observe that it's a kind of a classification problem kind of a data where the target value is either 0 or 1. So here our purpose is not to apply any machine learning algorithm for a classification task per se. Here I just want to show you that if suppose you will get a data with respect to classification or with respect to regression based problems, so what are the things that you should have in your head, which is very much must? Apart from that, obviously, a lot of things may vary depending upon the data that you have, but these are the things that you should take care of. And again, the prerequisite to understand this video is that you should have a good understanding of over the stats concept that I already have covered up in my separate playlist named Stats for Data Science. So now let's get started and we'll try to utilize the concepts that we have studied so far in stats portion in this EDA part. So let's get started. First of all, what I will do is that I'll try to import all the required libraries that we have. For example, here I will do import pandas as PD, import numpy as NP, okay, import cbone as SNS. So as of now, I'm taking the libraries which I feel we will use that. But if suppose if we don't use it, that is also completely fine. One more thing for the visualization purpose, for plotting the graphs, I'm using matplotlib.pyplot as PLT. So this is the first task that we are doing here, or I am doing here, that is to import all the required libraries, or you can say packages, anything will work. Okay, now once this part is done, you can run this. By the way, the platform that I am using is Google Colab, and this is available for everyone. You just need to go to the Google web and just type Google Colab. Here on the left hand side, you will observe that there is an option of uploading a dataset. Either you can connect your data with the drive itself, or you can upload your data manually. So what I did today is I have uploaded this. So I hope you can see this file by the name of diabetes.csv. This is what I have as of now to show you the demonstration part of EDA. Okay. So now our packages or libraries will get imported. The second task is to show you, or first of all we need to read the data and then only I can show you. So read the data set, okay, which is available in the form of a CSV file. So what we can do is we can say data is equals to pd.read_csv, and here what we can do is we can copy the path where the data is available and just paste it out here. Done. Once this is done, I can show you the topmost 5 records by using the head function. So what we can do is we can say data.head, and once this is done, you will be easily able to observe the topmost 5 records that we have in our data. Now here if you will observe, this data includes the features like pregnancy, glucose, BP, skin thickness, insulin, BMI until the age. And you can clearly see, right, the final thing, the target value is something that we have in this particular dataset is the outcome, which is having value either 0 or 1. That's why if you remember in the few minutes back, I told you that it's a kind of a classification problem that we're trying to solve. Now, okay, it's fine. The important thing that we need to now start is the EDA part, like how basically we will be able to get acquaintance with the data that we have And once we will be able to do that, then only we can prepare our data, then only we can clean our data, right? So let's get started. Let's see how many number of records that we have in our data. In order to check the number of records, the rows and the columns, we can use a function called as shape function. So this shape function will give you the rows, comma, the column value. So if you will observe, you will be able to get that there are 768 rows as of now in this particular data set that we have, and 9 number of columns that you can clearly see. If you really want to get a proper list of data that you have, you can just simply type data.columns, and you will be able to get a list which includes pregnancies, glucose until the value of age and outcome. Now, if suppose you want to see that what is the data type of each and every column that you have. So in this way, what we are trying to do is we are trying to get acquaintance with the kind of a data given to us. So this is a step-by-step process that we need to follow. So for example, if you will write data.dtypes, you will be able to get the data type of each and every column that is available in this particular data. So now you can see, right, pregnancy is glucose until the value of outcome, you will be having integer or BMI, and diabetes pedigree function is of float type. Now, completely understandable. I believe it is completely fine until so far. The next important thing that we need to understand here is that, okay, this is what the data type is all about. Suppose I really want to check the statistical description of this data. So there is a function called as data.describe. If I just tap on this function, you will be easily able to observe that there are a few things, I believe 1, 2, 3, 4, 5, 6, 7 and 8 things which is available. Now, if you all remember, we have talked about in our statistical part what is mean, what is standard deviation, what is 25 percentile IQR, I hope everyone remembers, 50 percentile, which I can say as the median, 75 percentile, the maximum value present in that particular record, the minimum value present in that particular column that we are talking about. For example, for every particular, if you will see column that we have, what we are trying to do is, this function will try to do is, this will check how many total count of different values that we have. What is the mean of that particular column? What is the standard deviation of that particular column? What is the minimum value present in the pregnancies column? What is the maximum value present at that pregnancy column? What is 25%, 50% and 75% value? Similarly, for every particular column, you will be able to observe these 7, 8 values, which are the statistical values that we have. In a way, if you will observe in the above part, we have observed that there are 768 rows. And in the count part, you can see that for every particular column that we have, we will be having 768 count only. What does that indicate? Can anyone get an inference of that? Just pause the video and try to write in the comment section, what does this indicate? If you will remember, we will be having 768 records, and this count also indicates 768 value. This clearly indicates that there is no as such null value present in our data. In other sense, you can also check it out by writing data.isNull, okay, dot sum. So this is the way. So isNull is a kind of a Boolean function which will return to you the true and the false value. For example, if I'll just run this particular thing, and if I'll just show you, you can see that it's a Boolean kind of a category. And if I'll write sum of that, you will be able to get the number. Now here you can clearly see that for every particular column that I have, I will be having 0 null values. So this particular function is null.sum indicates that the number of, I would say, number of missing values, or you can say null values, anything you can write it down, null values in any of the column that you have in the columns. Okay, so this is how basically we will be able to get an idea that how basically we can compute the number of null values present in any of the column that we have. So with the help of above intuition also, it's one and the same thing. Either you are doing with the help of this particular function, it's just that I just want to show you the things. That's why I have written this particular function. Otherwise, there is no need as such. Why? Because in the above part of the description itself, I concluded that if the count of all the columns that I have is same, it means that there are no null values, because this count is exactly equal to the number of rows that is available inside my data set that I have. I hope it makes sense to everyone. Now, the next important part that we need to understand here is we need to see that, okay, this particular record is something which is fine, that there are no null values. That's also amazing. But that is fine, but sometimes what happened is we usually ignore the part that, okay, there is no null value, data must be clean, data must be correct. But if I just observe this particular data more carefully by looking into it, maybe by looking topmost 50 records, if I'll say, and if I'll just show you again, just try to observe this data again and try to get more acquaintance with this particular data that is given to you. For example, here you can see that in BP, there is a value 0. Now, you only tell me that is there any person who is, taking a breath as of now, who isn't die and is having a BP value 0? Is that make sense? No, right? It means that this particular data does not contain any null value as such, but it contains zeros, which doesn't make sense to us in a particular data that we have. Because in order to determine that whether a person will be diabetic or not, there are so many features that we have in this particular data which is having value 0, and it doesn't make any sense. Doesn't matter whether the person is having a diabetic value 0 or 1. So what we're supposed to do is, we're supposed to do the imputation of this 0 value, right? There is no null value, that is completely fine. But this 0 value is something which is very, very dangerous as of now, which seems to be dangerous. So we need to do the imputation, maybe applying some algorithm. For example, usually people used to apply, so many different kinds of algorithms in order to get the prediction that what is a suitable value that we should write here, right? Apart from this, KNN they can apply. Apart from this, they can do the imputation with the help of a mean, median or mode. Now, you can ask me one question, that how basically we can do, okay? So, how will we decide that whether we should go for the mean value or the median value or the mode value? So mode value is something which is quite useful when you will be having a categorical kind of a data, where if suppose there is a very high frequency of some category, you can impute it with that particular category itself. That's completely fine. But what will happen with respect to mean and median? How will you decide? Again, this is one of the most important interview question, which very frequently asked from you as well, that in a data imputation, whenever you are doing a imputation with respect to any missing value or 0 or any null value, how will you decide that whether you should go for mean or median? Again, pause the video, because all these questions which I am talking about just now, I already have covered up in a theoretical sense in one of the videos in the stats playlist. So when I was discussing the topic of mean, median and mode with respect to the measures of central tendency, at that point of time I discussed all these points. So let's see who will be able to give me the correct answer in the comment section. So the answer is, it completely depends on the outliers. So how many number of outliers do we have? If suppose there are more outliers present in any of the column, in that particular case, median is something which will impact very less with respect to the outliers. So you can do the imputation with respect to the median. But if there is a scenario where there are very less outliers, or the distribution is kind of a symmetric distribution, in that case you can do the imputation with respect to the mean, right? So that is something which you have to determine. So with this, another concept which came into picture is that how basically we will get to know that which particular feature contains what kind of outliers and how many outliers are there. For that, again, just refer the stats playlist. So this is how basically now you will be able to observe that whatsoever concepts we have studied in our stats concepts playlist is making sense to us, right? So now what we can do here, maybe you can try to create a box plot. You can try to create a box plot where you can see that how many number of outliers are there. Now the question is how we can create a box plot. So here you can use that SNS library, inside that there is directly a function called as box plot, which you can call. So here what I can do is I can take a figure and the axis, which is equals to plt dot subplots. Okay, and inside that I am defining the figure size, which you can define it at any of the size. For example, I am defining 20 comma 20 here. After that, I am calling the function sns.boxplot, and here I can call my data, which is equals to data itself, and ax is equals to ax itself, which we have defined. If you really want, you can save this image, but as of now, let me try to run this. Okay, so this is how basically I will be able to get a box plot. What I can do is I can save this image, plt.savefig, and I can mention the image name as boxplot dot maybe png. Okay, so what will happen is now this particular image will get saved here, and I can download this image. Once I will download this, I will try to open this image, and then I'll try to show you what I really want to say. I hope this image is pretty much clear to everyone. Now here in this image, this is something that we have as the box plot. Here if you will see the lower part, if just focus on the glucose column that you have, this is something which where my cursor is going on is something that we called as lower whisker. This is something which we called as the value of Q1. This is something middle line is something, this is what we called as Q2, the median value. Above line is Q3, and the above arrow is something which we call as upper whisker. So if you remember, when I was teaching the box plot, I have talked about the 5 important values, and I have shown you the numerical example that how basically we can compute these 5 values. What is the value of lower whisker? What is the value of Q1? What is the value of Q2? What is the value of Q3? And what is the value of upper whisker? And these values of lower and upper whisker we will be able to calculate via the value of IQR. Do let me know in the comment section again, how will you calculate these values? Let's see who are the people who remember the concepts that we have already been covered up. So here you can clearly see, right, in the insulin portion, there are a lot many outliers. Now again, another question which can come up is how you can remove these outliers. First of all, let's try to remove these outliers, and after that, maybe once you will be able to get a very lesser number of outliers, you can try to do the imputation either via mean or median, depending upon how many number of outliers do we have. For example, in insulin, is mean is the better idea to do the imputation? No, never. In insulin, it would be better if you will do the imputation via median. So here if you will observe, this is how basically we will be able to get the box plot. We will be able to plot the box plot. Now, how we can remove these outliers? Again, there is a concept of quantile. I hope you already have watched my videos of IQR. See, again, I am referring those videos of stats because I already have taught those concepts and I am not creating this video for the very first time without teaching anything. So that is not the scenario, and that's why I want that stats playlist to be already matured, so that when I came to these topics, I can refer those topics. I can tell to you that, okay, first of all, go and refer those points and then come here. Okay. So now the concept of quantile, with the help of that, you can easily able to delete the records or remove the records. For example, here you can see that there is a blood pressure outliers are there. The lower 3 and upper, there are too many, but it's visually, it is like very few. So here you can see what you can do is you can call the quantile function, and what you are saying is get me the records which are falling under 99% quantile. What I can do is whatever records which fall less than that particular value of Q, that is something which I am calling as the new data. And what I can do is now what will happen is the records which are not falling under this particular constraint will get removed in this particular new data that I have. And again, if I try to plot it, if I try to plot this, you can see that in the BP part, there are now lesser outliers as comparable to the above one. I hope you can see the difference between the above diagram and the below diagram. So the concept of quantile will play a very crucial role, and it's not only for BP. You have to adjust these values, the number of records with respect to the columns that contains so many outliers. For example, insulin. I'm not doing for each and every particular column now. I have just talked about the concept, and this is your research work. I will share this Colab file in the description of the video. You can download this file, and then on top of this file, try to make the changes, and then you can maybe attach the final version of your file in the GitHub of your repo, make it public and attach in the comment section, so that I will check it, review it, and then do the comment that whether it is fine or not. I hope it is quite clear to everyone. So what you can do, I'll attach the file in the description. You can make a final version of this file. I'm giving you the suggestions that what things you need to improve on top of whatever I'm doing here. After that, once you upload in your GitHub, make it public and attach the link of that GitHub URL in the comment section of this video so that I can review it. Okay, let's move ahead. So this is the discussion about the box plot. What other things we can do? So here we can see that how basically we can detect the outliers, how we can remove them. Apart from this, it might happen that there are 9 columns that we have. Okay, out of that 9 columns, 9th column is something which is the target value. That is also fine. The 8 columns, it might happen that all those 8 columns are not that much crucial. Means there is a concept of feature selection. Now, how we can do that? There is a concept of correlation coefficient heat map. And in that particular scenario, what you're supposed to do is, you're supposed to create a correlation heat map to check what are the features which are quite useful. So feature selection technique, again a quite useful technique. What is correlation coefficient heat map and how it is computed? Again, I have already discussed the logical understanding of the same in my stats playlist. So here, if you will see, what you can do is you can define the figure size, the dimensions of that, plt.figure, and here you can define the fixed size is equal to, maybe let's define as 10 comma 10. Okay, and now here you can define ax is equals to sns dot heat map, and here there is a function called as core. Okay, and I want the annotation value to be true because I want the matrix to be annotated. After that, if you really want, you can save the figure. Otherwise, I can directly call the show function to show that image. Now, once this is done, you will be able to see a heat map which contains a correlation values. For example, here you can see that pregnancies and outcome, how much they are correlated. It is 0.22. Now, it's a matrix where I will be having for every 2 features, what is the correlation coefficient? What will happen if the 2 features are highly correlated? That's the biggest question which can be again asked from you in any of the interview. So if the features are highly correlated at that point of time, the inference is like they are indirectly giving me the same information to predict any outcome which is 0 and 1. So what I will do is that, suppose there are multiple features which are highly correlated, I will remove all the features and take any one of them, right? So that is something which is a feature selection technique. Now again, this is again your research work. I have already created that. See the numbers and check and do let me know, is there any feature in this particular dataset that we have which is highly correlated and we can remove that. Okay. Now moving ahead, apart from this, what other things we can do is, I told you, right, you need to see the distribution of your columns that you have after deleting the outliers. How will you check the distribution? Whether it's symmetric or whether it's non-symmetric. If it's symmetric, you can do the imputation via mean. If it's non-symmetric, you have to do the imputation via median, or you can apply any algorithm as well to do the predictions. For that, you have to apply a sns.distplot function. So what you can do here is, you can apply sns.distplot function, but after removing the outliers, do this, that would be great. Data dot, what is the column that you have? For example, if I want to see the insulin distribution, let's see. Can you see what you will say? Is this symmetric or non-symmetric? I hope you all know, right? What is symmetric distribution? A Gaussian or normal kind of a distribution. What is non-symmetric? it is something which is a non-symmetric. Do let me know whether it's a left skewed or a right skewed distribution. Again, there are so many questions. Write it down and again answer me all the questions. Okay, so this is something which I was talking about is a skewed one, where there is a high need to do the imputation via a median, not the mean. Again, if you will do the via mean, you will be going in the wrong direction. Now, apart from this, apart from seeing, so what you can do at your home is try to check the distribution of all the columns that you have and accordingly decide what you can do to basically impute the values. Okay. Apart from this, the next important thing that you have to do in specifically classification task. So this is a classification task. So it is applicable over here only to check whether the records or whether the data is balanced or not. Again, a very important task, because if your data will be biased towards one of the class, at that point of time results will go wrong. So how you can check that? You can take the outcome column that you have, so you can just write it down, outcome. There is a function called as value underscore counts. What will happen is it will give you the count of the unique classes that you have, and you can clearly see that for the zero number of classes there are 500 records, and for one number of classes there are 268 records that we have. It means for the class belonging to 1, almost half of the records are there, but for 0, 500 records are there. Now this is something which we called as a data imbalance problem, because data should be 50-50. It's not like that 20% data belongs to one class or 30% data belongs to one class and 70% belongs to 0 class. At that point of time, what you're supposed to do is you're supposed to apply the techniques to resolve this problem. For example, there are techniques called as undersampling, where we will maybe remove the records belonging to the upper class. For example, for 0, if there are 500 records, I will remove few records and make it a count like 268. Or you can do oversampling, where you can increase the sample size of the class belonging to 1. There are other techniques as well. This is a separate topic which I will create for, with a separate video, because if I'll go towards the depth of this particular session, this particular part, then the session will be too much huge. To resolve the above issues, below are the techniques. Okay, below are the techniques, and we'll discuss in very detail in the upcoming videos. Okay, but I'm telling you so that you can do your own research if you really want to do. Now, moving ahead, apart from this, what other things we can think of? What other things we can think of is the imputation. For example, if you will be able to get to know that, okay, insulin contains non-symmetric kind of a distribution and I have to do the replacement with a median, how will you do that? So, it's quite simple. What you're supposed to do is, I'm just telling you one again record. For example, you will be having a data of insulin, right? What you really want to do is, you will be having a data of again insulin, and it's quite simple. There is a function called as replace function. You can call this function and you can say wherever 0 is there, replace that value with a data of, insulin dot median. Okay. So in this way, what you will do is, you are saying that whatever records are there where 0 is there, you are replacing it with median. And now it is done. If you really want to check that whether it is fine or not, you can clearly check it out. Okay. You can clearly check it out by looking into that, is there any number of zeros are there or not. So if I'll do data of insulin dot value underscore counts, and here I'll define 0. Let's see what we will be able to get. Okay, let's do one thing. If I'll just write this data of insulin dot value underscore counts. Perfect. If I'll do here 0 and count of 0 is equal to like this, what will happen? Data of insulin, how many number of records are there for the insulin category? Let's see. Okay. It is not showing me the correct result. Let me check for the same thing for the BP. It is showing me 35. So why it is not showing to me? Because it doesn't contain the values, right? In the BP it contains, that's why it is showing to me that there are 35 zeros are there. But here it is not showing to me, it indicates that there are no zeros which is available. So this is how basically you can do the replacement in any of the record wherever zeros are there with respect to the mean or the median. So this is all about whatever I want to discuss in this particular part of the video. So what we have discussed in this today's session, we have discussed how we can read any data, how we can able to find out the data type of every particular data column that we have, how we can check the records, number of columns present in a data, how we can do the checking of the missing values, how we can do the imputation, how we can check the distribution, how we can create a box plot, how we can remove the outliers. All these things are the things that I really want you all to take care of whenever you are doing a EDA part of any of the data that you have. Now, in this particular live session part, I have not did the implementation for every particular column that is usually done. So this is your assignment. Try to complete this particular Colab file with the EDA task that whatever points I have shown to you. We have also seen that how we can create a correlation heat map, right? And what's the importance of that. With this, let's end this video. I am waiting for your responses for all the questions that I have asked from you while doing the session part. And with this, happy learning to all. Bye-bye everyone, and I'll see you all in my next video. I hope you find the session insightful. If you do, please hit like button, and I'll see you all in my next upcoming videos.